molar mass, counting atoms by weighing them. So the mole concept, what it is a mole of anything is Avogadro's number, which is 6.022 times 10 to the 23rd particles. Okay, so that means that it can apply, it's a counting unit. It's the chemist dozen. So when you have 1 mole of anything, it's Avogadro's number of that item. It's a counting unit. For example, if you have 1 mole of something ridiculous, a bowling ball of bowling balls, you would have Avogadro's number of bowling balls. There aren't that many bowling balls in the world, but hypothetically that's how many you would have. But where this is useful, as I'm getting everything back into frame, is for atoms, molecules, and things, ions, things that are extremely small. You do have this many, and many more times than that. So this is a useful counting unit for chemists. So application for this, if you have 1 mole, let's just say aluminum, that means you have Avogadro's number of aluminum atoms. Okay? And the same would go for other elements on the periodic table or for molecules. If you have 1 mole of water, again you have Avogadro's number of water molecules. Okay? But each of these have a different weight, and that's back to the topic of counting particles by weighing them, that concept. So if you look and reference the periodic table, you see an atomic mass. That tells you both the mass of a single aluminum atom, but it also tells you the mass of 1 mole of aluminum atoms. So if you refer to that, to the periodic table, you will see that 1 mole of aluminum weighs 26.982 grams. That is the mass of 1 mole of aluminum. And it can be applied to molecules or formula units for ionic compounds. Water, if you look at how much that it weighs, you add the molar mass of hydrogen times 2, because you have 2 moles of hydrogen in 1 mole of water, and 1 mole of oxygen in 1 mole of water. Again, where that's coming from. 2 hydrogen atoms per molecule, or 2 moles of hydrogen per 1 mole of water. Okay. You use the subscripts there. But if we add those numbers together from the periodic table, we see that 1 mole of water weighs 18.015 grams. So in summary, maybe a little smaller, hopefully that'll fit together. To summarize that, a mole of aluminum or a mole of water contains the same number of particles, but they have different masses. They weigh a different amount.